Hello, everyone, and welcome to another Code Remix Weekly stream. I'm your regular host, Sam Snyder. Not joining me today is Tim. Uh, he told me where he was going to be and why he was out, and I'm sure it was a very good excuse, but I forgot it. Based on what he's been up to recently, it was probably either attending some conference where he no doubt gave a talk that went very well, or possibly doing some fun sports thing, camping, climbing mountains, you know. Riding on a wakeboard behind a boat. All of these are kind of fun things. We had talked about a wolf pack menacing him in the distance, so on a previous Code Remix Weekly stream. So hopefully Tim hasn't been eaten by wolves, but we won't know until he comes back. And so without having him around to banter with, I guess there's not much for me to do but jump right into our announcements, which are that today is your last chance to register for tomorrow's advanced open rewrite training, which will be held at a very European friendly time and a very Pacific West Coast United States unfriendly time, as this is starting at something like 5 a.m. my time. So you won't see me there because I'm not going to wake up early enough for that. But if you do want some advanced open rewrite training or basic open rewrite training, and this time is not working for you, well, we're doing this monthly, so you can just register for next month's either intro or advanced classes. And I should be around for the intro and advanced classes that are at West Coast friendly times. We also have a webinar coming out about doing code maintenance at scale with AI. This is going to be a 30-minute virtual panel, which includes big names from Google, Meta, DX, and of course us Modern, about how using AI can be transformative for software development and all of its implications on software maintenance and reliability of reliability of maintenance activities. And so that should be a lot of fun from our side. Jonathan Schneider, our co-founder, is going to be there, as it's going to be moderated by the popular and effervescent Ruse, who is a fixture of the San Francisco tech scene. On the Open Rewrite kind of technical news side of things, we have put out a migrate to Java 25 recipe, which should help everyone to adopt that new stable, long-term supported release of Java. Our migration recipe has a few different little things in it. Taking advantage of the new process wait for method, taking advantage of a few new small features. This recipe so far doesn't include much in terms of taking advantage of new language features, but it will get you using some of those new APIs. I haven't actually tried it out, so maybe we could just give that a shot in a second here and see what it looks like. Run it live. But first, there's been an OpenRewrite patch release, 8.62.1. A couple little bug fixes in here. No major feature changes. And let's see, that is building on top of 8.62.0, which we told you about last week. Yeah, which came out exactly 1 week ago. But if you missed that, this has a few more features in it, in addition to many bug fixes, as always. There's always more bugs to fix, I find. So let's take a look at the new Java 25 recipe, and maybe I will just use the recipe builder. And this was something Tim suggested. I'll use our recipe builder to Java 25 only to just get a preview for your benefit and mine. So like I said, I haven't run this yet either. To get a bit of a preview of just the Java 25 features. As you all know, our recipes are kind of recursively composed out of each other, but I want to see just the 25 specific stuff. So for now, I'm going to remove the migrate to Java 21 step from this. So we have only the Java 25 specifics, and we can just kick that off and see what kind of changes that this might suggest. So oh, here we go, getting some results already. Of course, you have stuff like updating build.gradle files in order to use the new number. New Java language version supports using underscore for ignored parameters, so you need not name a parameter that you are not going to invoke anywhere. I expect we will see a lot of that one throughout these diffs. Many exceptions that are not cared to name. Of course, some updates to CI configuration and YAML files. Let's see what else. Let's see what else we got. Oh, here we go. There's a problem updating this one in an automated way led to the recipe leaving a search result marker. This is something we've talked about doing sometimes, but I haven't seen many recipes actually do it. So that's kind of fun to be notified, like, hey, this probably needs a manual update since the recipe wasn't sure what to do with this named parameter when it was presumably expecting a number. Yep, here's another variation of using the unnamed parameter name, this time in a lambda rather than an exception handler. So yeah, I guess if you're tired of seeing names for variables that don't need them, this recipe will make a lot of changes along those lines. I'll go ahead and cancel this. So cool, yeah, Java 25 upgrade now available. Give it a shot. Let us know what shortcomings, if any, it may have. And of course, we accept pull requests to add things in if you found such a shortcoming and want to be proactive about fixing it rather than just reporting it to us. Okay, and so that kind of brings us to the main subject of today's stream, which isn't actually this post-quantum cryptography recipes I was working on, but are in fact traits. Now, traits are something that we have talked about a little bit before on this stream, but it is kind of an advanced feature of OpenRewrite that that is not always well understood. And if we look at the trait interface, it's pretty simple. It's a cursor and a tree, which of course cursors contain a tree element. A tree element, of course, being just any given fragment of an LST. And the idea here is that embiggen my text. And the idea here is that that a trait is a way of building a higher level uh, abstraction over an LST element. So you, y- there are many things that an LST element might mean that are specific to some domain that I just clicked over and noticed some of the comments that I had been missing in the live chat. Uh, Jada looking up effervescent, but the yeah, so a trait is a higher level abstraction over an LST element, and which can be converted into a few things. And so we have a few examples of traits in the main code base. Like if I go to the trait interface, uh, that we can look at some of the things these are used for. So here's a good example, the annotated. The annotated trait represents elements that have an annotation on them. So, an annotation can appear in many different places within Java code. Even within the source file itself, we see an annotation being placed on a class declaration, and an annotation being placed on a variable declaration, and a method declaration, and annotation being placed on an inner class, annotation being placed on a method on that inner class. And so this idea of things that have an annotation is there's like common operations you might want to do on any kind of thing that has an annotation, like getting its default attribute, or getting the regular or getting some other attribute from it. And these are kind of like shared behaviors that exist over more than one type of LST element, or involve more context than can exist on a single LST element. And so traits are a place where you could put shared logic that you want to reuse across many recipes that you might otherwise, create like a utility class for, or something like that. Or you might want to like, you could imagine like the like get default attribute method or get attribute method, that this might be something that you would want on anything that could have an annotation on it, right? That this might be a method that you'd want to go add to, method declaration and class declaration, all of these other places. And this trait concept provides an alternative to stuffing the LST elements themselves, just like totally chock full of extension methods to cover every possible domain. Trying to balance keeping things extensible with having like a simple public facing API. So let's maybe look at another one. So here's like the Gradle dependency trait. Now, if you're familiar with Gradle build files, there's a number of different ways that dependency declarations can be done, right? You can have this string notation. There's also a map notation, and so if you want to have one kind of like syntax element or one tree element could have many different representations with the same meaning, then you could abstract over those different representations with a trait like the Gradle dependency trait, so that you could get out the name of the configuration and the group ID and the artifact ID and the version for any recipe that didn't care about the particulars of whether it was string notation or map notation. You could make a trait that understands both and then provide a common interface, a common abstraction, which encapsulates those differences. And I mentioned, that the traits were kind of an alternative to like creating utility classes or other forms of extension. But I didn't talk about why you would prefer something like this to one of those. One of the reasons you might prefer that is, a unified interface for receiving, testing if if an LST element implements a trait, or can be interpreted by a given trait. And the other is that a trait can always be converted into a visitor, so that if you, for example, wanted to see the world not in terms of like the normal the normal visit methods provided by Java Visitor, but just wanted to see all of the elements that were annotated, or all of the elements that were Gradle dependencies, or all of the elements that had some other trait on them. Well, you can use the as visitor method on a trait in order to convert that into a visitor that will visit all of the things that implement that particular trait. So it's a way of filtering down to just what you're interested in as a recipe author. So this is all kind of like high level stuff. Let's give an example of a trait that you might want to use yourself. And so if you go into Rewrite Recipe Starter, which is of course our example recipe module that we've shown many times on this podcast, vlog, whatever this is, I will post a link in the chat to this particular source file. And yeah, there we go. And so this is an example trait that could be used in a recipe to track comments that have the word "to do" in them. Like, say you wanted to write a recipe that took all of the comments that still had the word "to do" in them and produced, say, a data table, so that you could look at across your whole code base a list of all of the places where someone had left a little informal note. Hey, someone should really do something about this, even though I am committing it as is. So, let's say we have this this track to dos recipe. which is kind of set up to be a placeholder so we can implement this trait. And we'll close all of these irrelevant files and just focus on on this one. And so if we look at like a test for this, we can see that kind of the objective of this recipe is to, across several different kinds of source files even, track different kinds of comments that might contain the word to do, and crucially to ignore comments that don't, right? This is a trait that is some but not all comments have. So, if you wanted to, for example, have a visitor that visited all of your to-do comments and did something with them, you could use the trait as visitor method in order to get back a visitor that only visited to-dos. And so, we're here to go look at here to make all of this work. And we see that these tests are asserting that both to-dos in a YAML file as well as to-dos in a Java file all get found, and that a data table is produced that has rows noting the file and the comment and what kind of LST element had the to-do comment on it. So if we were to go just run this test right now, we'll probably see that absolutely nothing happens because we haven't gone and implemented this code yet. Yeah, very good. So if we go look at this recipe as it currently exists, we see that it has basically no implementation. So what we kind of want to do here in order to, I think populating this data table is our first order of business, is that we want to match, let's see, we want to match things that are comments. So do comment matcher. Yeah. So one thing, when I talked about converting a trait into a visitor, I could say turn new to do comment. Yeah. Yeah. So this would say get cursor. Yeah. Here we go. So the idea here is that this is that when you take a trait, you first get a matcher, which is what is going to discriminate between LST elements that have this trait and LST elements that do not. And if we then convert that into a visitor, what will get passed into this Lambda function are all of the cursors that point to LST elements, or all the to-do comments that point to LST elements that implement this trait. Now, we haven't really implemented this yet. So, if we go and run these tests, this breakpoint that I've placed inside this visitor is still not going to be hit by anything. All of these are disabled, so we should probably undisable some of them so that they will run and start failing and start showing us the various things we need to do to make this happen. And yeah, I probably could have removed all of those disabled faster, but that's fine. Yeah, I guess that's running now, but yeah, now that the tests are actually running, they're not making any changes. And if I debug one of these, we're not going to hit the breakpoint here because this hasn't been implemented yet. So the first thing to do to start making this trait a thing is to make the matcher actually match things that are to-do comments. And we see that the matcher, which is by convention, is implemented as a static inner class of the trait, extends this simple trait matcher type which just has this one method test, which has a cursor passed in, and all we need to do is implement these parts of it to see if to pass the test. Cool. So this is already set up in here with the it being kept in mind that this transcends the boundaries of a single language, as you could have a to-do comment in many kinds of document formats. And we'll kind of do Java to start. So what we're going to say is if we're visiting something that's of type Java, well, I want to traverse over all of this, and so I will. Yeah, okay, so this is going to go test everything. So all I need to do is I need to get the space from it. Everything has a, I get the prefix. And I'll look inside this to look inside its comments, and we shall iterate over the comments, and we shall look for the word to do. Now, the thing about in Java or in the Java LST is there's several types of comments. I mean, you got your single line, your multi-line, and your Java doc style comments, and each of these is a slightly different representation. So we'll say if comment, let's do our basic text comment to start. Oops. So if comment, I got a new keyboard, so if my typing is a little bit awkward, I will blame that. So if our comment is a text comment, I can get its text. And so I'll say if you contains to do, then I'm going to to-dos dot add tc, and we already have a cursor, right? Cursor. Is that backwards? Oh, no, it's just, we don't need to put the cursor in there because it's going to be happening later. Okay, so we found a string with the word to do in it. We're going to add it to our list of to-dos. Yep, and we found this to do have fun comment that is from this guy here. And we found to do test your code, which is from this guy here. So both of these are text comments. And then are we going to run into, yep. And so now that we've, now that our matcher has matched a few elements, when we use this matcher and turn it into a visitor, we will hit this breakpoint where we'll get back the to-do comments that were matched by the trait. And we see that this method declaration that we were visiting earlier has two to-do comments on it: have fun and test your code. But it did not pick up the just a regular comment, because in our trait we are only looking for things that have the string to do inside of them. Okay, so now that we've implemented the beginnings of our trait matcher, we can start to fulfill the promise of populating a data table with our findings. So let's see, the data table is already here. So I will just say insert row. Oh yeah, that is a challenge for the data table here. We don't actually have a an execution context. So I think in this parameter, so I think what we will do, actually, is there an as visitor override that does pass through the execution context? Yeah, here we go. Yeah, there is. Like this. Yeah, so there's a variation that has it. And it looks like our surprise special guest has arrived. Tim, how you doing, buddy?
Just fine. Yeah.
Earlier, I was speculating that you were doing extreme sports or possibly being attacked by wolves or coming home from a conference. Possibly all of those at the same time. Was I close?
Close. I was doing something maybe similarly perilous, which is taking a Dutch train and banking on that you'll make it home in time, which didn't quite work.
Are the Dutch trains famously not as punctual as you would like?
Well, they're quite functional unless something very, very strange happens, like a bit of rain, some falling leaves, or just a general, I don't know.
Yeah. Who has the best train reputation in Europe? I feel like I've heard plenty of people complaining about the trains in their country. Who's got it best?
Probably the Swiss. I think they're the only ones who have like scenic trains that people take for pleasure rather than just
Yeah.
the monotony of trying to get to where you have to go. And
Yeah. I have taken a couple trains in Switzerland, and it was very nice. But I also had a good experience when I was taking the trains in the Netherlands. But it's true that I wasn't in a real hurry to arrive at a real specific time.
But I'm here. It's good. I was able to follow the live stream. You demoed 20 Java 25 pretty well.
Oh, thank you.
So
I'm glad you think
thanks.
so. Uh, so let's see. So here, to fill this out, we want the source path as well as the type of the element. So we want to get the source path. That is on the top level element of each file, which is the source file. And this is where it starts to be handy that this to-do trait, or that all traits have a cursor passed in. Excuse me, have a little, I don't know, heartburn or discomfort or something. So that lets us go up to the top level element and get the path off it. So I can say to do, and I want to get the cursor, and I want to get the first and closing source file. Nope, not source set. That's the wrong kind of source thing. Get the first and closing source file, get the source path. And I assume this is taking this as a string. And yeah, we're a little worried that it might be null, but tell you what, it's not going to be null. It's fine. And here we can say to do comment. Oh, right, but there could be multiple ones on each. So what I need to do is get to do's. I need to iterate over this. To do, wonderful name. And so here is where we can say to do, and this is where we can say, I don't know how relevant it is what the type of the LST element this is attached to is, but it couldn't hurt. We'll say to do dot get. I think the main point of having this here is to show you that you can get out the original element. Okay, and so this should be something like, not passing this test yet, but closer to it. I think this test will fail for two reasons. One, we're not actually generating this source file under todo.md. Yeah, I was expected to generate this source file. For now, since I've started with populating the data table, maybe I will just comment out this assertion so that we could be, well, if I don't comment out too many lines anyway, I just comment out these lines, no trailing commas allowed. So this should at least allow me to, oh no, wait, I've switched over to the XML test. That's not even the right test, or not even the test I'm running. Something wrong with it as a test, but it was this create new to-dos file Java is the one that I am trying to run. Okay, so what we should see happening now is our data table includes at least some of these rows. And assert J, Tim's favorite assertions framework, will point out for us exactly what the discrepancies were. So we were expected to produce these, and we actually produced these. And I see that there's an extra space here that I could probably trim off. But aside from that, this looks good. So let's just go back to our. I guess we go back to. We do it in the trait itself.
And I've indeed today been giving a presentation about over an hour on a search tree and how to best use it to the full extent.
Nice, nice. Okay, so let's see. So what is different? What is different between my elements? Source path A, comment to do, have fun. Oh, it includes the word class in there. Suggest get type name. I don't remember which is which. Some elements not found, some were not expected. This looks right. A.java, to do, have fun. J.method declaration. To do, test your code. Tim, since you just gave a presentation on this, do you see what the difference is between?
I don't see a clear difference.
Oh, it's
So what
the expected has the word class in it, and I've taken the word class out. I see.
Well,
I don't think the word class
think
is that useful here. You think we what now?
Oh, well, we have a reference implementation, of course, so I was eyeing that one at the same time.
That's true. Yeah, we could obviously either. Yeah, there we go. But yeah, it was just the word class appeared in the element type, which maybe you would care to know that it was a class rather than an interface or an enum or something. But well, this is the type of the LST element. They're all going to be classes. So yeah, I'd say the word class is something that we wouldn't need to include in there. Okay, so this is now passing because we have because we've implemented the trait at least sufficiently to detect these kinds of comments and produce a data table with these contents. We don't have it actually producing a file with the to-dos yet. So we might as well do that while we're here. Let's uncomment this. And this isn't strictly about traits anymore. But yeah, so in the scanners, we are returning a new to-do comment, but this will show us. So this we need to do in here is we're not going to support markdown files, so we don't have to worry about it finding things. Okay, so what we kind of need to do here is we need to do this and another thing. We need to do this. We need to visit all elements that are of this type trait, and we need to just visit everything to see if anything we might find is this found to do file. So instead of returning this directly, I could go return a new tree visitor. I'll override its visit method, not the version that includes the parent. And by convention, call you CTX. And here I can apply both this trait matcher, and I can apply the populate the this accumulator. So in here I can say the tree. We're only going to visit the top level element here, so I'll just cast the tree to source file and get source path to string. And so if to-do.md equals this guy, we'll set this equal to true. I got my parentheses right. Although, frankly, I could simplify this down just to this expression. A little or equal in there. Okay, and so now we have this check for found to do file, and we need to also use our to do comment matcher. And so this is where I can say, here's the visitor, and we don't need the CTX form of that, as that will just be captured. And I will just say, hey, you visit the tree with the CTX. And so this goes away. And now our scanning step does both. It both finds if a to-do file exists, and it finds everything that matches this trait and adds a data table row for it. So now we could use this information. I guess we could go looks like the way this is set up is the idea is that we would load all of the comments into here, and then in the generate step, we would probably do all of the writing stuff to a data table and what have you. So let's see. I guess I could say just say to-dos dot act dot to-dos dot add to do, and we'll save this part for later so that we have a nice simple accumulator which does just its two things, or a nice simple scanning step which is just those two things. And in the generate override, because this is a scanning recipe, we can iterate over the list of to-dos and emit them into the data table. So you can say act.todos is empty. We'll just do an early return. Like if it's empty, we're going to return an empty list. So we don't need to generate nothing or emit anything into the data table. And we could say if act.todos, if the file doesn't already exist, so if act.todo file is false, found to do file, we shall create a new to do file. And for this, we could use their plain text parser, build map. And we need to, as always, when we produce a new source file, we got to set the path on it with source paths, paths.get, do.md, so the framework knows where to put this file when it is done. And I'll leave actually populating the contents of this file up to the edit step. I mean, when we're creating the file completely from scratch like this, we could collect, not to set, to list. When we're, we'll do that here. And you're probably just complaining that, yep, there we go. And return collections.empty list. Okay, so we'll leave actually populating this file up to the edit step. So there's just one code path that modifies its contents rather than two. Okay, and so before we return early from this file, let's put it back in. Put back in the part where we produce this data table, so we can iterate over our list of to-dos. To get to-dos, to do, and CTX. We wanted to say, what do we call this data table again? To do comments table. Insert row, CTX, and all the stuff we did before. To do, get cursor, versus get source path to string. And then to do, and to do get tree, get class, get type name. Okay, and so now this test should pass as we're producing both the data table and the new source file. Oh wait, no, it shouldn't pass because I haven't done anything to actually fill in the contents of this file yet. But we can go ahead and run the test and see how we've done. See if I regressed the data table or if I reorganized that correctly. Always worth double checking. I never trusted any code I've written works until I've have a passing test about it. Yep. So yeah, we're as expected. We need to actually go modify the contents of this file to include everything we have found, and we'll do that in the edit step. Also known as the visitor, and so we'll return a new tree visitor. We'll override the visit method. Actually, we could do all we need is to visit plain text files, this markdown. So we could do a new plain text visitor. New plain text visitor. And we'll visit the text. And we can use a precondition here so that we only visit files named todo.md. We'll just wrap you around. So new find source files todo.md. So now we know this visitor will only modify source files with this path. And so here we can return ACK to-dos. Well, let's see. We probably want to. We can do this all as like one string join, basically. ACK to-dos dot. This is our linked hash set of to-do comments, and I could stream them and collect. Yeah, flat map. Get to-dos stream, and then I could collect, and it's string.joining, right? Is the name of the collector?
I think so.
String.join. There was a collector to join. Collectors.joining, that's it. And so this, we have a delimiter, a prefix, and a suffix. And so for our delimiter, we can join them on lines. For our prefix, we can put in our header. Was that a configurable parameter? It is a configurable parameter on here. Whoops. Let's keep that. We can make our prefix header, and our suffix is null. And I'll collect you to text. No, I'll call you different. Body. I'll call you body. And we'll return text with text body. And this should be pretty close to passing this test. Let's see how we're doing.
I'm expecting some white space changes still.
There's probably some white space changes. Oh yeah, I should probably put a line break in at the end of that header. I guess we can just we could probably do something intelligent like check if the header already ends in a line break and only add one conditionally, but this is for educational purposes, so we don't need to worry about every little edge case in such exquisite detail. There we go. And so now our test is passing. At least this test is passing. You'll note that we haven't implemented anything for Javadoc style comments. We haven't implemented anything for YAML files. We haven't implemented anything for XML files to track to do comments. And I think we could probably mostly leave these as an exercise to the reader, that if you would like to try this out for yourself, well, you could see us doing a very similar exercise interactively with you in one of those OpenRewrite trainings I mentioned. This would be in the advanced training. So if you come, if you're going to be there tomorrow morning, you will see Tim and Merlin, I believe, is going to be with you, Tim.
Yep.
Explain traits in a little bit more detail than this and flesh out the rest of these use cases. But for now, I think this has given you an introduction to the concept. So next time you're like looking at an LST element and we're like, man, I wish I could tell if this was a blank, if this had some property. I want to reuse this functionality or this piece of knowledge over many types of LST elements or LST elements in more specific contexts. Particularly if you want to reuse that logic over multiple different recipes, a trait could be just the place for that. Yeah, so I think this is probably a good place to leave our trait exposition or expo for the day. Do you have anything to say to the people, Tim? Since you're here now, you rushed back with all fervor and all haste, so you must have something important to tell everyone.
Mostly that I'm looking forward to next week's episode, where we're going to have a more detailed look at Java 25, which of course came out
Yes.
yesterday. Hopefully with a special guest. We're working out the details yet. But we're going to show you a bit more about both recipes and parser support that we've built out. And then, hope to have you all by then either already migrated or at least enticed to do so yourself.
Yeah. Hopefully, just as an industry, we'll be staying more up to date on Java versions, thanks to tools like OpenRewrite making it easy to do so. Yeah, our main OpenRewrite repository has already added Java 25. Obviously, we had to in order to support it, but we're going to quickly moving that and all of our other repositories over to actually be running on it as well. So that will be fun. So yeah, by next week when we're having that discussion, we'll be able to perhaps share some of our own impressions of having moved a software company to run on the latest JDK.
And of course, there's a lot of benefits coming with it as well, like compact object headers and new garbage collectors and potentially performance improvements. So looking forward to exploring all of that with you all next week.
Would always love to see performance improvements. It's always nice when you upgrade something and then everything just works better than before. It feels like such a freebie.
Absolutely. So,
anyway. I think this is a good place to leave things for this week. So thanks all of you for joining us. Thanks Tim for joining us as well, and we'll hopefully see all of you next week.
Yeah. Cheers.
Cheers. Thanks, and bye for now. Oh, don't forget to like and subscribe.